Well, good morning, everyone. Welcome back to the second day of Virus Bulletin. Welcome in the Red Room, where we actually are starting our last-minute presentation series. I know that, like me, you all have cell phones. Can you please put them on at least silent so we are not interrupted? Thank you for that. The first last-minute presentation is by Jaromir and Jan from Avast about malicious proxy autoconfigs. Gentlemen.
Good morning, everybody. I hope you feel well after yesterday. And the main topic in these days is without doubt the ransomware. For example, the Loki and these new variants like the Zepto, Odin. But we should not forget even on the other malware. And like the malware, like using the malicious auto proxy configs, etc., which is a really easy way how to harvest banking credentials from the unaware users. So today, we'd like, sorry. The guys, can you please swap the screen? I'm sorry. So, today we'd like to talk about the proxy autoconfig. Then, because we choose the RedFA banker, which is really active in these days in the world, so we would like to tell us something about the history of RedFA banker, and we'll compare with the new version which appears this year. Then my colleague Jaromir will tell you something about the infection vector of RedFA, then about the installation of the malware, and we'll show you the examples of the fake bank from the new countries affected by this malware. And of course, there'll be time for the statistics and the questions. So let's start with the proxy autoconfig. The proxy autoconfig defines how web browser automatically choose the proxy to fetch a given URL. Actually, it's a really useful thing. You have server preference functions, which can be really useful when you working with that. But unfortunately, it can be easily misused by the malware authors. It must contain JavaScript function, find proxy for URL with two parameters, URL host, which can return three different values. The direct, that the connection should be made directly without any proxies. Then the proxy, which must contain host and port, which specifies which proxy should be used. Or the SOCKS, which also have two similar values, the host and port, and will specify which SOCKS server will be used to fetch the given URL. Proxy autoconfig can be set up manually in each browser, or it can be set up automatically from the predefined addresses. So you can see that there is the proxy config for the Internet Explorer, Chrome, etc. So let's start with the history of a RedFA banker. In the past, it used to be the OLE file embedding executable file, rar SFX, malicious CPL, etc. And the reported countries targeted by malware were Switzerland, Austria, Sweden, and Japan. The first mention about RedFA was in February 2014 on the Microsoft blog. Then the first white paper was published on the Trend Micro blog. And the first talk about RedFA, called The Circle Around RedFA, was published by Peter Cruz on the Carol workshop in 2015. When we compare it with nowadays, it's still the OLE, but it's embedding JavaScript, and it drops PowerShell scripts to install fake certificate, and both the JavaScript and the proxy autoconfig has really simple obfuscation, but there's some changes. It may install additional tools like the Tor, Proxify, etc., and also the persistence may be added, which are the biggest changes from the older version of the RedFA. So from nowadays, the first mention about the new version of RedFA was in April 2016. Actually, there were two really interesting blog posts about it. And since the June 2016, the RedFA started targeting the United Kingdom banks also. And it was described in our blog post in June and July 2016. And now my colleague Jaromir will tell you something about the infection vector, and we'll go through the technical details of it.
Okay, thank you. So now let's look at the infection vector. So basically, RedFA is distributed via spam emails. So the victims usually get email, and there is the attachment with document. And when we open the document, you can see that there is a small picture, and under this picture, there's the written message. Double-click on this picture to see it bigger, to see it more clear. So you can see the screenshot on the right side of this page. So when user double-clicks on this picture. It tells him to say some security warning that he tries to open the package content, and it might not be safe. But still, if the user clicks on the OK button, the infection starts. There's like one thing, like it doesn't use any exploit kits, and nowadays we see a lot of documents which use macros, and there are usually like some kind of notes like open the document, enable macros, enable contents. This is not the case. There are no macros, just embedded JavaScript file. The document is document X, which is basically a zip file. And if you look inside of the zip file, there are like many other files. There are usually some XML files, which we are not interested now. We are the most interested in one file, usually called like ole object bin, which is like binary package. And this package contains the JavaScript file itself. We have seen like many different campaigns. They are usually targeting German-speaking countries, and the name of the file in this package usually contains some German names like Rechnung, Bestellung, Zahlung, Quittung, Paket. These are usually, in translation to English, it's like invoice, order, package, and something like that. So now if you want to look inside the document, inside the JavaScript file, what we can see, so there is usually some kind of text or some kind of document which is obfuscated. In this screenshot which I'm showing, it's obfuscated by online tool called JavaScript Obfuscator, but of course we can see different obfuscator. The obfuscation is very simple, so there are no other tricks. So if you wanna unpack it, deobfuscate it manually, you can replace eval by document write, and you get the deobfuscated content. From the deobfuscated content, we can quickly notice that there is like one kind of class or variable called config, and it has some other variables or values. And from the meaning of the values, we can very easily identify what it is about. So the first one is DL. There are some .onion domains. So these are CNC servers from which the malware downloads the latest configuration. There is one value called cert, which is the certificate, which it later uses for signing the fake bank websites. And there are also two, or in some versions, 3 files. In this screenshot, it's named like PS or PSF. There are some PowerShell files which have some additional functionality, which I will describe later. For the core function of this JavaScript file, basically the malware targets the 3 main web browsers, which are Internet Explorer, Chrome, and Firefox. And for each of them, it calls the 2 functions like install certificate and install proxy autoconfig. It also, to refresh the configuration, it needs to kill the currently open browsers. So there is some function called close all browsers, which kills all the open browsers via task kill, and so on. So in case of Firefox, in Firefox, the configuration is stored in prefs.js file, which is saved on the disk somewhere on profiles directory in Mozilla directory somewhere in user's profile. And it needs to change some configuration because in Firefox, it can have its own default network proxy settings. And if these settings are set, basically malware needs to delete these settings, and after that, the Firefox will use default Windows proxy settings. So it goes through the prefs.js, it deletes all the lines or all the values which contains network.proxy. And also there is the value called block.onion. So to be able to access .onion domain, this item needs to be deleted if present. For installation of this certificate, they use certutil utility with some parameters like add store, -f, -user, and so on. And when you use this tool and try to install new certificate, it usually displays this kind of security warning. It's telling that it's installing some new, in this case, certificate authority, and if you agree or not. So this would happen, this shows to the user, this is shown to the user, but only for a short while of time. because like one of the PowerShell scripts, which I mentioned, contains some functions. And if I want to describe these functions, as you can see in this slide, so first it enumerates all the processes which are currently running on the computer, and it finds, or if it founds the process either CSRSS or certutil, then it goes further and enumerates all the windows which are associated to these processes. And there is a comparison. If the malware wants to see, wants to identify the currently displayed dialog box, it has some predefined class value. So it compares this value. In this particular case, according to MSDN documentation, it's 32770, which is class for the dialog box. And if this one is found, then it uses the handle of this dialog box window as one parameter to send message. And send message command uses another parameter, bmclick, which basically simulates the clicking of user to the yes button. So if you are on the infected machine, if you start the infection, it very shortly appears, and after a short while, the dialog box disappears, and basically certificate gets installed. If now we want to see all the installed certificates from, for example, Chrome web browser, we can open the settings and see the trusted root certificate authorities. So these, in the red mark, there is like one new extra certificate, which is like some Commodore certificate, and the issuer value has me at myhost.mydomain, so which is clearly something suspicious. So this new certificate is added. This is description of adding certificate to default Windows Store, which is valid or which is used by Internet Explorer and Chrome. But for Firefox, it's something different. It works a little bit different because Firefox has its own certificate store. So malware needs to use another specific functions to include this malicious certificate into Firefox cert store. For this, there is like, in the beginning I managed that there are a few PowerShell scripts, and one of these scripts, it was called PSF, like F like Firefox, and this one adds the certificate to Firefox. It calls a few functions from NSS3DLL library, and there are 3 main functions. All of them start with cert_prefix. There is the function called getDefault certDB, which gets handle to this certificate database. That function imports this malicious certificate, and then when this certificate is imported, it needs to change some flag or some bit, which is called certDB trusted CA. So it sets this bit, imports the certificate, and malicious certificate is also included into the Firefox. When we are looking at this part of code, I found that part of the code was probably inspired by some thread or some forum in exploit.in, when one guy had, I think, the same code written in C++ or something, and he wanted to port it to other language, and it looked very similar. So it's possible that malware authors often share some parts of code, so it might be inspired by this thread or by people active on this forum, but just speculation. We cannot tell it for sure. For the proxy autoconfig URL, it's stored in registry in value called autoconfig URL, which is like underlined in this figure. And if you look at it, there are like few like static strings like .onion, .js, IP equals something, and the rest is random. The domain before .onion is random, the name of the file is random, and IP address is something specific, is the current IP address of the victim. It's also important like which IP address you enter, because we were researching the threat targeting UK customers, UK bank customers, and if you put there any different IP address from UK, which doesn't belong to UK IP range, it displays some error, like nothing found. However, if you try the correct IP address, which we found, basically you can enter something, any IP address which belongs to UK IP range, We got something which we can see in the figure below. There is the configuration file. It's a very small one, again obfuscated by something like Dean Edwards Packer, which is easily recognizable. The file is small, usually a few hundred bytes or few kilobytes maximum. And after the obfuscation, it looks like this. There is, as Jan mentioned in the beginning, find proxy for URL function. Then there is proxy variable, which tells what is the proxy server which should be used. There is an array of bank websites which are targeted. So if address URL, if URL in address bar corresponds one of these hosts' addresses, then the proxy is used. Otherwise, as you can see in the end, there is return direct, then nothing is used. We have seen like few different versions. Some of them were like simple as I described, but in one case, or in few cases, we saw that the RedFA downloaded additional tools and additional programs. Like one of them was Tor, another one was Proxyfire. One thing which we should mention about the Tor, if you download it and run it, you can usually see like a small black window of command line. And in case of infection, we couldn't see anything because it calls the show window function and puts their parameter to hide it. So the Tor was running in the background and nothing was visible to the victim. When you are using Tor and when you try to access the web, you usually get some random IP address. So at one time you can be in one country. After some time, your IP address is changed to another country, and so on. Of course, it depends on your settings, but this is the default one. So they also need to know like what is your current IP address. So they use Proxyfire, and it's the screenshot in the right, that there are like some targets, and for few targets, the action is like direct. So basically, the Tor proxy is not used. And one of these IP addresses is called api.ipfi.org, which is the service which tells you your current IP address. So they need to know if you are in UK, they need to know that you have like UK IP address. So they put like few exclusions to the Proxyfire, and we think that that's the reason why they use that. Also, Tor and Proxyfire could be disabled or found or deleted by users, or ended. This process could be ended by user. And to avoid this, they add some persistence. And for persistence, they went to one website called Codeplex. And on this website, they have the project called Task Scheduler Manager, which is a project which has few DLL files. And when they are installed into the system, it allows them in PowerShell to simply call function addTask with two parameters. The first parameter is the name of the task, and the second parameter is the path of the file which should be started. So as you can see, like in these screenshots, the bottom one is adding the persistence. The name of the persistence or the name of the task is called like Google Update Task or Adobe Flash Player something. You can notice like the second line, Adobe Flash is without the space, which is in the regular one. And in the blue bracket, there is the name of the file which is being executed. It's like proxyfire.exe. And all this happens with a period of 30 minutes. So if any of these services is not running, after half an hour, it's restarted again.
Fortunately, but surprisingly, the RedFA banker does not use any additional keyloggers, etc. So they only harvest the data from the fake bank sites. Usually, the requested credentials are the credit card number, social security number, mobile phone number, security code, etc. Usually, the data which are need to access to the bank sites. Also, they are using the fake certificate, so it's really hard for the victims to recognize they fall in the trap of this banker, because fortunately, sometimes we can see the banks using the certificate with extended validation, like the Barclays Bank. So there's a small chance that the user can notice the extended validation marker is missing. But usually people don't much pay attention to this stuff. Also, the authors of the RedFA using the really simple social engineering. So they are using the counter to delay user action. So usually they show up the 3-minute marker or counter to delay all users' action, like to closing the website, etc. So they can use the harvested credentials to steal the money from the account. When we look into some bank sites, for example, this is the Intelligent Finance. This is the legitimate website. This also already contains the warning about the new malware targeting United Kingdom banks. But when you compare it to the fake website, it's really similar. Only the changes are there is no warning, of course. And when the user fill up all the data, the counter appears. So they have a time to steal money, etc. And this counter stops when they reach 1 second. And so it can be suspicious for the user. So in the new version, for example, the Santander Bank, they use something very similar. Again, the user input all the data. There is the timer. But when the counter ends, the user is redirected to the error page. There's some maintenance or some error on the page. So they should try to come back later, like in several hours. We give the authors the additional time to work with the stolen bank account. Look on some more effective banks. For example, this is the legitimate website. Again, you can notice there are some small differences between the fake website and the original website. But what's more interesting for us, when we discovered there was also the Tesco Bank affected, when we opened the debugger, we noticed there is a sign the certificate is valid, but there are some debugging errors, like they cannot debug or parse the font, or the HTTP request was invalid, etc. But it's really hard for the user or victims to recognize this malware. When you compare the certificates on the left side, there is a legitimate certificate of the Barclays Bank with the extended validation marker. On the right side, there is a fake certificate signed by Komodo, or issued by signed by Komodo, certificate authority. Well, when we try to analyze this malware, we return, unfortunately, with the same IP address like a few days later, and we recognize our IP address was already banned by the attackers, so they really paying attention what's happening there. And when we try to connect to the website, the proxy autoconfig return us the direct value. So we were sent to the legitimate website, which returned us the error website with there's a technical problem, etc. So from the data in our user base, we can recognize the UK users are like only 4%, but it's still growing, this number. And still the most affected users are in the German-speaking countries like Switzerland, Austria, Deutschland, etc. But still, this is a really warning for us that this malware can spread up even to the different countries, because we found some people from France also received this email with the RedFA banker. So we're expecting there will be some evolution of the RedFA banker, so we need to really focus on this malware. Also, when we check our data, the numbers are not so big. In there, it's like the hundreds or sometimes thousands of people affected by this malware. And we can see there are the campaigns peak during the days. These are the data from the last 5 months. And we can see there's already like 10,000 of people who received the email with the RedFA, or the RedFA was run on their computer. So the RedFA banker used a really simple but still really effective social engineering tactic used to trick banking customers. They are not using the macro, so that there is no enable content or enable macros needed. In the new version, there was added new target country, the United Kingdom. They completely moved from the executable file to the scripts, like the PowerShell scripts, JavaScript, and also the additional tools like the Tor, Proxify, etc. were added, and also the persistence was added to these new versions. And both proxy and config URL right now are behind the Tor, so it makes it much harder to analyze. So thank you very much for your time. And if you have some questions.
Well, thank you. Do anybody has questions for the speakers? Can't see that side of this. No, I couldn't see that side because of the desk.
So
There is no
hopefully
one,
it's
good. Okay, so we can actually see that there's a lot of progress in the development of this. Can you elaborate a little bit on what banks could do to harden their processes to that this would actually be much more difficult to be used?
Like the banks, what can do?
Yeah, the banks.
Well, actually, for banks, it's really hard. They can use
Use the
the.
microphone.
Oh, sorry. So the question was for the banks, yeah. So the banks can start using the certificate with extended validation, which is really easily recognizable because the new certificate doesn't use it. So it's one part what the banks can do. And I think the second part, they should like try to more tell their customers, like show them how to educate the customers a bit slightly more. But I know it's really hard because the people don't want to educate themselves usually. The same problem in this industry.
Anybody else has a question for Jaromir or Jan? There's a question there.
Yeah, is there any of these banks that have you seen using pinning that avoids this man in the middle stuff?
Using what? I didn't hear.
Pinning, certificate pinning.
No, like I think like certificate pinning is a little bit different. It's not used in this case.
When did they use HPKP or something like that? The bank, so the browser alerts that they're not the real certificates. Have you seen any case in this?
No, we haven't seen.
Okay.
Any further questions? If not, please join me in thanking Jan and Jaromir.